Hello and welcome in. Mark here, aka the Markster. This is video number 85 in the FreeCAD series. Today we'll be looking at the Honeycomb Macro, which is what I use to create this lid for this box. You close this document, discard changes, create a new document. The first thing, let's install the macro. You can do that from the Tools menu, Add-on Manager. We can also get to the Add-on Manager from the Macro menu, Macros, and here where it says Add-ons, if you click that, it also brings up the Add-on Manager. The Add-on Manager has been given a little bit of a facelift in 0.20, but not in this particular build that I'm using today. So if you're using 0.20, it might look a little bit different from what you're seeing here. So in here we have the Workbenches tab and a Macros tab. And the other, I believe you have a little drop down box to choose Macros or Workbench or all. So once we get to the Macros tab, we can come down and look for the Honeycomb Macro. So there are actually three Honeycomb related macros. You have Honeycomb Solid. Let me get the magnifier up here. And you have Honeycomb. Honeycomb is the one we want today. There's also one more, let me show you. FC Honeycomb Maker. I'm pretty sure I did a video on this one already. This is the sort of older version of the Honeycomb Macro. This one I wrote back in 2020, and the new one I wrote this fall in October, 1 year later. This one creates a spreadsheet and some other objects. The new one creates only the Honeycomb object. It's a feature Python object, so this is an update to that earlier macro. Probably I will be removing the older one once 0.20 becomes the new stable, because the older one does have the advantage of working with some Python 2 builds. So if you're still running 0.18, one of the Python 2 builds, or 0.17 or 16, then that macro still works with those older versions. But I will most likely remove it from the add-on manager when 0.20 becomes a new stable. This Honeycomb Solid macro was written by someone else. I did not even know that it existed when I wrote Honeycomb. I only discovered it as I was adding Honeycomb to the add-on manager. So it's very similar. It does not have a border, and I don't believe Honeycomb Solid is parametric after you save it to a document, close FreeCAD, open FreeCAD again, open a document again. I think Honeycomb Solid will be broken. Honeycomb does not suffer from that little drawback. So we install it, select the macro, click install here. I'm not going to do it because it's already installed on my computer. If you did it from here, if you went to the add-on manager from here, you need to close it and open it again for that list to be updated. I think so anyway. So now we go down to Honeycomb and you run this file, execute right here. Notice I've got Honeycomb with a capital H, FC Macro, and lowercase Honeycomb Pi. This lowercase file is created when you first run this file, Honeycomb FC Macro. So the first time you run that file with your permission, the Honeycomb Pi file gets created. And this Pi file you do not run directly, but this is the secret to making the Honeycomb object remain parametric after shutting down and restarting and loading a file containing one of the Honeycomb objects. So that's what the purpose of this honeycomb.py file is. You don't run it directly, you run the FC macro file directly. If at some point you decide this is not for you, I don't like this macro, it's a piece of garbage, you want to uninstall it, then you need to delete both of these files. And you can do it from here, just click the delete button to delete both of these files one at a time. Okay, let's go ahead now and execute the macro. So it takes a few seconds, on this computer about 5 seconds, to create the first object. It's a little bit computationally intensive because it has a lot of little Boolean operations it does with all these different little hexagons. The more you have, the longer it takes. So if we look here in the tree, we have the honeycomb object, and if we select it, it populates the property view, and you can see all the different properties associated with the object. So we don't have spreadsheet and a couple of different arrays and some Boolean objects like you have in FC Honeycomb Maker. You just have a nice little clean tree with just one object in it and all the properties right here at your convenience. So let's look at these properties and see what each one does. The first one I'm going to draw your attention to is the radius property. Radius is the circumradius of each individual hexagon, and by default it's 1, which stands for 1 millimeter. I keep FreeCAD in millimeter units. If you use inches, I don't know what that's gonna be. I'll be honest, I haven't tried it. But this is a floating point value interpreted as millimeters. Sorry to all of you Neanderthals out there still using inches. Okay, I do too. I use inches. I just don't use them in FreeCAD because FreeCAD is designed and built and tested in the millimeters. That's what they use. And inches are supported, but it's kind of an afterthought. So that's why I just leave it in millimeters. So the circumradius is the circle that contains all of these points on its perimeter. And the radius of that circle is what this radius property points to. The bigger the radius, the fewer hexagons we need to populate the grid. The fewer hexagons we need, the faster the recomputes. You see that connection there? The bigger the grid, the bigger the hexagon, the fewer you need in the grid. The fewer you need, faster the recomputes. So what we want to do is set this to some big value initially, get all the other properties like we want them, and then at the very end adjust this radius property back down to the desired size, because it's going to take it maybe a minute or more to recompute, depending on the size of the overall grid, depending on how small this radius property is. The default is quite small. The default overall grid is 15 by 10 millimeters. So 10 in this direction, 15 in this direction. Quite small. So most likely you'll need to enlarge that. And I'm going to recommend to make radius much larger than you need initially. So I'm going to put this to 50. Now 50 is bigger than the whole thing. So naturally you're going to have a failure message. Don't worry about that. Once we set the other size bigger, it'll work its way out of that little jam. So I'm going to say let's make one that's 150 by 200 millimeters. 150 by 200. 200 here. And so even with the big hexagon, that took a little while to recompute. So let me clear this error. I right clicked on the report view. Clear that error, so if we get another error, it'll catch our attention. Alright, now let's look at some of the other properties. We have separation here. This is the wall thickness. So if we go from 0.5 to, let's say, 3, give it a few seconds, and you can see how that changed. So the distance between this edge and this edge is this separation property. Separation of the hexagons within the grid. Now let's start at the top. Border height offset. By default, this is 0.1. That's 0.1 millimeters. The border height offset. Let's zoom in here. Zoom in carefully. So this border is a little bit taller than the grid, and that's 1/10 of 1 millimeter. So that's the border height offset. The bottom is flush. Bottom of the border is flush. The top has a little bit of an offset by default. You don't want that offset, put that to 0. You can even go negative. Okay, put it back to the default. So what's the purpose of that? It's just another way to tweak your honeycomb. And if it's at 0, and if you're offset, let's look at the border offset. I'll put it back to 0 just to show you. If we set the border offset to a negative value, -1, you see it's set inwards with a negative value. And if you set it inwards, then you have these little extra lines showing. There's a refine property that should take care of that. Refine equals true. But for some reason, it fails. So the border height offset can just make it look a little bit better on the screen. But when you print this, those edges don't matter. They won't even show up in the final product. So border offset can be negative for an inset or positive to offset outwards. If you don't want a border, set border offset to 0, and you won't have any border at all. So I'm going to set this border to 5. Height. Well, let's do the elliptical grid property first, since that's next in the order. Elliptical grid can be true or false. If it's true, you get the elliptical border. If it's false, you get a rectangular border. If you want circular, then you would use elliptical and set the width and the length to the same value, and that would give you a circle. Now let's go to height. So pretty simple, that's the height. Let me set it to 10 just to show you. So that covers both the grid and the border. So length we've already covered. That's, if you're looking at it from the top here, that would be the length from front to back. And the width property is from left to right. This is the diameter in elliptical mode, and this is the distance across in rectangular mode. Radius we already covered. Separation we already covered. X adjust and Y adjust. Let me get the little magnifying glass back over here. X adjust and Y adjust. That adjusts the grid within the border. So let me set this Y value to -5. And notice how it moved down. So that moves back and forth. And the X adjust goes left and right. So if you want to adjust that within here, like if you wanted to center this, you could adjust the Y adjust property for that. There's no point adjusting it now, because at the end we'll set the radius back to a smaller value, and it would need to be adjusted all over again. It might even adjust too far. If you go too far, you'll have a void inside the border, because this grid extends beyond the border, what you're seeing here, like one hexagon more all around, to give you that wiggle room to be able to make these adjustments. But if you go too far, you're going to end up with a void. So you should have enough room to do whatever you want to do as far as centering. But if you find that you're not getting what you're looking for, try going in a negative direction instead, or positive if you were already going negative, and see if you can line it up that way. So that pretty much covers the honeycomb object. It can be used in part design workbench. It can be used in part workbench. It's actually a native part design object. It can be used with mirrors, patterns, for example, polar patterns, whatever. It can be attached, just like the other part design primitives, just like these objects. So basically it's a part design additive hexagon, additive honeycomb is basically what this is, but it also can work in part workbench. You see it's not in any body right now. If we select it and create a body, it added as a base feature. That should not happen. Let's drag it into the body instead. Now it goes in as a native feature. And at the end, like I said, we can set the radius to some smaller amount. Let's go to 5. And it's going to take it a few seconds to recompute. While it's doing that, let me give you a little bit of trivia. The honeycomb, of course, is named after honeybees, the honeycomb that the honeybees make for their nest. And it turns out that this honeycomb pattern is the most efficient use of material that you can have when creating a grid of cells. So in each of these cells, of course, the queen bee lays an egg and a bee eventually comes out. So all of these have to be manufactured by the bees, right? They go out and they collect the material and they come back and they turn that into this nest. I'm not sure exactly what process they're using. Maybe it's chewing it up and spitting it back out. Maybe it's excreting some enzyme. I don't know. But I do know this. It's some work. It takes some work. It's expensive to create all of these little grids. So you want to do it in the cheapest way possible if you are a hive of honeybees. And it turns out that this honeycomb grid is the most efficient use of that material. If you laid it out in a traditional matrix, straight up and out of squares, you'd end up using more material for the same given wall thickness than if you laid it out in a honeycomb fashion with hexagons. So nature has found the most efficient way. Maybe there were bees at one time speculating here. They laid theirs out in that rectangular pattern, and because they were not as efficient and had to spend more money, so to speak, more time and effort collecting more material, they did not survive. They were not able to compete with these more advanced honeycomb producing bees. So I'm only speculating on that, but I thought it was interesting. So if you need to lay out a grid of cells, the honeycomb pattern will use the least amount of material, so you can save on 3D printer filament, just like the bees save on their bee making material by using the hexagon grid pattern. So that's going to do it for this video. We're nearing 30 minutes, 26 minutes worth. I think I've covered what we need to cover, and I thank you as always for watching, and I will see you in video number 86.